Hi students, good evening. Welcome to this video session. My name is Samuel Dominic Chukwu Emeka, aka Sam Dom for Peace. In this video session, we shall discuss your final exam. Are you excited? Thank you so much for all your hard work so far throughout the course. You have 2 attempts for your final exam. You have 2 attempts for it. So you are not timed, which is a good thing, so that you don't work under pressure or work under time. However, you need to complete it within the due date. You can start your final exam, and if you have an emergency, you can close the test and come back later to complete it. Provided you do not submit the test, you don't click submit. If you answered some questions before you leave, your answer choices will be saved. Your answers will be saved. And then when you come back again, you can continue. I'm going to demonstrate in this video what I mean. We will answer some questions, then we will just go. I will log off. You just close the test. Provided you do not submit it, do not submit the test. Then you can come back and continue from where you stopped. If you submit the test, then that is 1 attempt. You have used 1 attempt. But provided that you do not submit the test, you can still come back and continue 1 attempt. When you have finished your first attempt, you submit the test. Then you go and review the questions you got wrong. I will show you how you can review that as well. So let's go ahead and begin. We click on the final exam. The final exam is comprehensive. It covers everything we have done throughout the course. So it is important that you have reviewed everything we have done throughout the course prior to you taking the final exam. It is also recommended you have finished all your homework assignments, all of them. You completed all of them, and that you have mastered them prior to taking your final exam. So I'm going to click on, this is 0 of 2 attempts. You click Start Test. In this final exam, the only question help you have is just your textbook and Statcrunch. Okay, that's all you have. We have done this, so to save time, I will just use, as usual, I will use my calculator and also Statcrunch as necessary. We have done most of this. Now with the final exam, it is not graded immediately. It is only graded when you submit the test, provided you don't click submit test. It is graded only when you submit the test. So we keep working, okay? And when we are ready to submit the test, we just click submit test. Okay, so I'm gonna go to my website right away. I will look for the mobile friendly one. However, you can just go to my website, and I'm just going to go to my portfolio. I'll click Samuel Chukwu Emeka App Spot. This is the mobile friendly version. You can click on portfolio or calculators. Okay, we're going to use several calculators here. So I'm going to pull up this, and this here mean median mode is descriptive statistics. So I'll come here and I'll click on descriptive statistics calculator to pull it up. And the mean median mode is measures of Senna. So I will get this measures of Senna. We have done most of this before. So we have done most of this either with Statcrunch or my calculator. So this should be familiar to you for the most part. Okay. 3960, I put in the data. 3960, 4090, 3200, 3100, 2950, 3830, 4090, 4050, 3580. Okay, let me read the question. A concrete mix is designed to withstand 3,000 pounds per square inch psi of pressure. The following data represent the strength of 9 randomly selected casts in psi. Compute the mean, median, and mode strength of the concrete in psi. So I used descriptive statistics calculator, and I just put in this, and I will click calculate. The mean is X bar 3650, so I'll put here 3650. The median is X meander, which is 3830. Median is 3830. The mode is X hat 4090. 4090. Okay, and that is it. So I press enter. Okay, and I go to question 2. Okay, now you make sure question 1 has been answered all the way, which I think we did. Question 2 is saying compute the range and sample standard deviation for strength of the concrete in psi. So we go to I'm going to open this up, and range and standard deviation is measures of spread. Okay, for some reason, technology sometimes. Let's see. Technology. So I'm doing this live, and I know that some of you probably you have this. Check your internet connection, wait for this, and that's fine. Okay, don't panic, just keep doing it. You might want to check your internet connection. My internet connection is fine. It's not allowing me to go to question 1. If I want to go to question 1, it's not allowing me. That's okay, I'll move on. Okay, I'll move on. I'll try this again, and that's fine. This is still one attempt. Okay, we can click here, we can click right here in the middle. Well, it says 1 complete. So if you look at this here, it's, yeah, so 1 complete means question 1 is complete. We can click on it and see it allows us now. Okay, so if you click on the arrow keys and it's not allowing you, just click on the center and then click on the question. Yeah, I just want to make sure that I completed this question 1. Okay, and then I go to question 2. So here we are looking for range and sample standard deviation. So I'm going to pull up my calculator, and this is under measures of spread. Measures of spread. I minimize this. Measures of spread, you have first method and second method. You can use any one. You can use any one. So I'm going to put in the values 3960, 4130, 3200, 3200, 2990, 3870, 4130, 4060, and you just click compute, calculate. Okay, the range is 1140. You put in 1140, and the standard deviation is to 1 decimal place is 478.0. Okay, 478.0. We put that 478.0. That is standard deviation to 1 decimal place. And you know, all this like is like showing your work. Okay, we do that, we press the enter key, and we go to the next question. Question 3. So I'm going to minimize this. Determine whether the random variable is discrete or continuous. In each case, state the possible values of the random variable. A is the number of people in a restaurant that has a capacity of 250 discrete or continuous. So number of people is discrete, and the possible values are from 0 to 250. Okay, but you know, you count it, you're counting it. So I'm gonna say it's B. The possible values, it could be nobody there. The capacity is 250. Okay, it could be nobody there, or 1 person there, or 2 people there, or 3 people there. If you select C, you can have maybe 2.5. Okay, so you just, you know, the best thing is to select B. Is discrete. If you can count it, it's discrete. If you can measure it, it is continuous. B is the square footage of a house, discrete or continuous. The square footage, you measure it, so it is continuous, and it is possible values are A greater than 0. Okay, because it must not be integer values, it could be decimal values. So that is continuous. And you see that your answers are saved. Okay, your answers are saved. If you want to change any of your answers, you just go to that question, and you can change the answers. Okay, let's do half of it, and then then I can show you what I mean. You can, if you have an emergency, you can just close it and come back again. I'll show you. The probabilities of events. Determine the required value of the missing probability to make the distribution a discrete probability distribution. So the sum, to make it a discrete probability distribution, the sum of all the individual probabilities will give you 1. The sum of all of them will give you 1. So, you know, I can pull up my calculator. I can pull up the calculator. Usually your calculator, maybe when you pull it up, it is in standard. You want to change it to scientific. I mean, I prefer scientific. So this plus x plus 0.29 plus x plus 0.22 plus 0.27 should give us 1. So if you want to find x, it will be 1 minus 0.29 minus 0.22 minus 0.27, and that gives us 0.22. Okay, so this is 0.22, because when you add 0.29 plus 0.22 plus 0.22 plus 0.27, then it should give you 1. The sum of all the probabilities is 1. Okay, we go to the next question, question 5. One graph in the figure represents a normal distribution with mean equal to 11 and standard deviation equal to 2. The other graph represents a normal distribution with mean equal to 16 and standard deviation equal to 2. Determine which graph is which and explain how you know. Well, let's expand this. If you expand this here, for A, the mean is 11. For B, the mean is 16. Okay? So graph A has mean 11, B has mean of 16. Okay? Option A. So it's either option A or option C. We eliminate options B and D. Okay? A has mean 11 and B has mean 16. So it says here, because a larger mean shifts the graph to the right, and option C, a larger mean shifts the graph to the left. Well, a larger mean shifts the graph to the right. Okay? A larger mean shifts the graph to the right. So that is option A. Question 6. Assume the random variable x is normally distributed with mean equal to 50, standard deviation equal to 7. Compute the probability. Be sure to draw a normal curve with the area corresponding to the probability shaded. So x greater than 34. X greater than 34 is going to be A here. X greater than 34. Okay? It's going to be A. And you want to find the probability. So I'm going to go back to my website. I'm going to use a probability distribution calculator. Probability distribution calculator. And I will go to normal distribution. Normal distribution. And I'm going to use this right here. I'm going to use this one. So let me minimize. Let me restore this. I'm going to use this one. X is 34. Mean is 50. And standard deviation is 7. Calculate. So calculating it, this is what I need, greater than 34. And that will give me 0.9889. 0.9889. So 0.9889. Okay. I'm gonna minimize this, expand this. Question 7. Fill in the blanks to correctly complete the sentence below. Suppose a simple random sample of size n is drawn from a large population with mean mu and standard deviation sigma. So this is mu, that's the population mean, and this is lowercase sigma, that is your population standard deviation. The sample distribution of the mean has mean equal to that and standard deviation equal to that. So this is your central limit theorem. Let me see if I actually stated it here. This is your central limit theorem. Get back to the probability distribution. Central limit theorem Okay, I didn't write the formula here, but it should be on the notes. It should be on my notes. Okay, so with central limit theorem, your mean is actually equal to the mean. It should be the mean, and then the standard deviation, the mean of the sample means is the population mean, and the standard deviation of this sample means will be population standard deviation divided by square root of n. That is the central limit theorem. Okay. Question 8. Describe the sampling distribution of the sample proportion. This is the sample proportion p hat. Assume the size of the population is 20,000, and this is the population size, 20,000. Then they gave you the sample size, which is 600, and the population proportion, which is 0.4. Okay, so I'm gonna use this calculator, and I'm gonna go to sampling distribution. And this is what I need here. I'll restore this. So this is if they give us the sample size, the population size, and the population proportion, and we need to find whether it is normal or not. Is it normal or not? And then we need to find the mean of the sampling distribution of the sample proportion and the standard deviation of the sampling distribution of the sample proportion. So I'm going to put in this. N is 600, the sample size is 600, the population size is 20,000, the population proportion is 0.4, and I'll press calculate. So let's look at this for a moment. So it says here the sampling distribution of the sample proportion is approximately normal. And why is it normal? You have to, this is the condition, that the sample size is less than or equal to 5% of the population size, and then the sample size times P times Q is at least 10, greater than or equal to 10. So let's pull up the question. So this is normal, approximately normal, because Q is 1 minus P. Okay, so this here, N is less than or equal to 5% of uppercase N, and then NPQ. Q means 1 minus P is at least 10. So the answer is D here. And then the mean of the sampling distribution of P hat is 0.4. I'll put 0.4. And the standard deviation of the sampling distribution of P hat is 0.02. 0.02. This is 1 decimal place as needed, we are good. This is 3 decimal places as needed, we are good. Okay. So we go to the next question. Question 9. Compute the critical value that corresponds to 84% level of confidence. Okay, so I'm going to pull up another calculator. I'm going to pull up inferential statistics calculator. This calculator right here for critical values. And I'm going to go to critical values. And they gave us, they asked us to find the critical value for 84% level of confidence. So this is, if we're given level of confidence, we need to find critical value. So this is what I'm going to use here. So the confidence level is 84, and we put percent, and you click calculate. The critical value, how many decimal places? 2 decimal places, yeah, I should know better. 2 decimal places there. So critical value is 1.40. 1.41, I mean. 1.41, that's the critical value. 1.41. Z-scores are usually 2 decimal places. So that's 1.41. Okay, from here. Question 10. Construct a confidence interval of the population proportion at the given level of confidence. So we have 99% confidence, sample size is 200, number of individuals with the specified characteristics is 120. Okay, we're gonna, they give us xn and ci, confidence interval, confidence level. They gave us x, they gave us n, and they gave us ci. They gave us x, they gave us n, and they gave us ci. Confidence level. Okay, they gave us x, they gave us n, and they gave us cl. Okay, and they want us to find ci. They want us to find ci. They gave us x, they gave us n, they gave us cl, confidence level of 99%. Then they want us to find confidence interval. And this is estimating population proportion. So still on this calculator, I'm going to go to estimating population proportion. Given, they gave us x, n, and cl, and they want us to find ci. So I'm going to use this. Okay. Confidence level they gave us was 99%. X is 120, n is 200. X is 120, and sample size is 200. Calculate. So the confidence interval is 0.511, that's the lower limit, and 0.689, the upper limit. How many decimal places? 3. Okay, so we have 0.511 and 0.689. So 0.511 and then 0.689. Okay. Question 11. Determine the point estimate of the population mean and margin of error for the confidence interval. So they gave us the lower bound and the upper bound of the confidence interval, and they want us to find the point estimate and the margin of error. So this is estimating population mean. I get back to this calculator, estimating population mean, you click it, and this is actually the one here. They want us to find the point estimate of the population mean, and the best point estimate of the population mean is your sample mean, and they also want us to find the margin of error. So let's look at the lower bound and upper bound. They gave us 15 and 27. So we come here, we put 15 and we put 27. We press calculate. So the sample mean is the best point estimate of the population mean, and that is 21. Then the margin of error is 6. So 21 and 6. This is 21 and this is 6. Okay. The following data represent the concentration of organic carbon collected from organic soil. Construct a 99% confidence interval for the mean concentration of dissolved organic carbon collected from organic soil. So they gave us the sample mean and the sample standard deviation, which kind of makes it better for us. Okay, So we don't have to, like, we already know the sample mean and the sample standard deviation. That's nice. Otherwise, we would have found it ourselves. But since they gave it to us, we'll just use it. And they want us to find a confidence interval, construct a 99% confidence interval. So we are given sample mean, sample standard deviation, and the confidence level. And we want to find the CI. We were given CL, which is 99%. We were given the sample mean, X bar, and we were given the sample standard deviation, lowercase s. So we get back on this calculator, estimating population mean. We were given, let's see what we were given. We were also given the sample size. Okay, they gave us the sample size in the question. So the sample size is 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4. Sample size is 20. It's 20. So this is what we're going to use here. Confidence level is 99%. 99%. You can also use 0.99, but you have to select decimal. It will still work. And the test here, of course, is we look at the test as one-tailed. Sample standard deviation is 7.91. 7.91. Sample mean is 16.98. 16.98. And the sample size is 20 from what we counted. Okay. Calculate. So the 99% confidence interval would be, actually this is 99%, not 0.99%. 99% confidence interval. So it's gonna be how many? Let's see how many 2 decimal places. Okay, so this will give us 11.92 as the lower confidence lower bound. Okay, 11.92 is our lower bound, and 22.04 is the upper bound of the confidence interval or interval estimate. 11.92 is the lower bound, 22.04 upper bound. So 11.92 lower bound, 22.04 upper bound. Okay. Question 13. Suppose the null hypothesis is not rejected. Okay. State the conclusion based on the results of the test. 6 years ago, 11.8% of registered births were to teenage mothers. A sociologist believes that the percentage has increased since then. Which of the following is the correct conclusion? So, if the null hypothesis is not rejected, that means there is not sufficient evidence, okay, to support the rejection of the null hypothesis. So there is not sufficient evidence to support that the percentage of teenage mothers has increased. Okay, there is not sufficient evidence to conclude. There is not sufficient evidence to conclude that the percentage of teenage mothers has increased. So that is gonna be B. Okay. I pressed the enter key. I thought this was homework. Oh, excuse me. Okay. Question 14. Test the hypothesis using the p-value approach. Be sure to verify the requirements of the test. The null hypothesis is that the sample proportion is the population proportion. P is population proportion. P hat is sample proportion. So null hypothesis is that the population proportion is 0.3. Alternative hypothesis is that the population proportion is greater than 0.3. Sample size is 100. The number of individuals with the specified characteristics is 45. The level of significance is 10%, which is 0.1. Okay. The first question is NP not Q not at least 10, and then it says use technology to find the p-value. Okay, so if you calculate this, actually it is we can use, I'm gonna use my calculator to do this, to test this hypothesis. This is hypothesis testing calculator is what I'm going to use, and this is one sample, and this is right-tailed test. So I'm gonna come here, hypothesis testing calculator. See how many calculators I've used so far. And this is that particular question is one sample left-tailed. Right-tailed, because the alternative hypothesis is to the right, greater than. So this is one sample right-tailed. Excuse me. So this is what I'm gonna use here, and I'm gonna use this right here. So I'm gonna restore this, and I want to restore this to put it side by side. The population proportion is 0.3, and that is decimal. X is 45. Sample size is 100. Level of significance is 0.1 decimal. Calculate. Okay, so the sample proportion is 0.45 times n times q. Q will be 0.55. If you want to see whether it's at least 10, let's see this. So n is 100 times 0.45 times 0.55. Okay, of course it's at least 10, greater than or equal to 10. So yes, the p-value is to 3 decimal places. The p-value is 0.999. Okay, 0.999. 0.999. So here the decision and the conclusion do not reject, and you have to get the same thing if you're using the classical approach or the p-value approach. It has to be the same decision and conclusion. The reasons are different though, but the outcomes are the same. Do not reject the null. Okay, do not reject the null, because the p-value is greater than is greater than alpha. The p-value is greater than alpha. Okay. So we've answered, we've answered. You go to question 15. So you have to go to question 15. Now it has saved this. So if you just if you have an emergency right now, or if you have an emergency you need to leave, just don't click on submit test. No, just close it. It says changes you made may not be saved. Click stay and then wait for some time, close it again, and just click leave. It doesn't matter, click leave. Okay, so we're gonna come back. You come back to this. You've closed it, and then you come back to it. You come back to it. If you refresh this, like, you can just close this also, it doesn't matter. But I don't want to sign off entirely. So it says here, if you log in again, it says this, 1 of 2 incomplete. You still have your attempt, okay? So click on it, and it says attempts 1 of 2. You're still on the first attempt, okay? You click on finish the test. Okay? And it still says here that 14 is complete. You see that 14 is complete. So it still saves your answer. Just once you answer that last question, go to the next question before you leave. Okay, so that it will save it. Like, we answered up to question 14. We finished it. Then we went to question 15. It saves it. As you go to a question, the next question, it saves it. Okay, before you now just close it, and then you come back again and you continue. Okay, so let's go ahead and finish this stuff. Let's finish it. Question 15. Researchers wanted to measure the effect of alcohol on the development of the hippocampal region in adolescents. The researchers randomly selected 14 adolescents with alcohol use disorders. They wanted to determine whether the hippocampal volumes in the alcoholic adolescents were less than the normal volume of 9.02 centimeter cube. An analysis of the sample data revealed that the hippocampal volume is approximately normal with the sample mean. The sample mean is 8.11 and the sample standard deviation is 0.9. Conduct an appropriate test at the 5% level of significance. So the null is that the population mean is equal to that, and the alternative is less than, less than normal. So alternative is that the population mean is less than 9.02. Okay, find the test statistic. Okay, so I'm gonna go to I'm gonna restore this, and I want to go to hypothesis testing calculator. There you go. So I'm gonna just refresh this, and this will be one sample left tailed, but under the population mean, okay? Because this is a mean, this is the mean. They gave us the sample mean and the sample standard deviation. We're gonna use one sample left tailed, so I'm gonna click on it, and I will restore it to be side by side with this. Okay, one sample left tailed. Let's scroll down. Testing hypothesis using classical approach and p-value approach. The population mean is 9.02. The sample mean is 8.11. The sample standard deviation is 0.9. The sample size 14 adults, 14. Level of significance is 5%, 0.05 in decimal. Calculate. Okay, so the test statistic we see here to 2 decimal places will give us negative 3.78. Negative 3.78. The p-value is 0. P-value to 3 decimal places will give us 0.001. Okay, 0.001. What conclusion? Reject the null. With both approaches, you reject the null. There is sufficient evidence to support rejection of the null. So reject the null. There is sufficient evidence to conclude that the hippocampal volumes in the alcoholic adolescents are less than the normal volume of 9.02 centimeter cube. Okay, that's it. Question 16. It has long been stated that the mean temperature of humans is 98.6 degrees Fahrenheit. However, 2 researchers currently involved in the subject thought that the mean temperature of humans is less than 98.6 degrees Fahrenheit. So this is still less than, so this is still left-tailed test. Okay, one sample estimate testing population mean, one sample left-tailed because of the less than here. They measured the temperatures of 148 healthy adults 1 to 4 times daily for 3 days, obtaining 500 measurements. The sample data resulted in a sample mean of 98.0 degrees Fahrenheit and a sample standard deviation of 0.6 degrees Fahrenheit. A. Using the classical approach, judge whether the mean temperature of humans is less than 98.6 degrees Fahrenheit at the 0.01 level of significance. Okay, that's 1% level of significance. All right. B. Approximate the p-value. Okay, so, and this is they gave us this distribution table, which I'm not gonna use anyway because I have my calculator. So I'm gonna restore this. We're still gonna use the same calculator here, but let's reset this, but we still have this here, so let's just refresh this. We will still use one sample left-tailed, and I'm gonna restore this. Then I will scroll down, classical approach, hypothesis testing hypothesis using classical approach. Here the population mean is 98.6. The sample mean is 98.0. If you like, you put 0.0. If you don't like, don't put it. It's still the same thing. 98 and 98.0 is the same thing. The sample standard deviation is 0.6. Okay. Sample size, how many adults? 148 healthy adults. Level of significance is 1%, which is 0.01 decimal. And you click calculate. So the classical approach reject the null hypothesis because the test statistic is less than the critical t-value. Okay, so reject the null since the test statistic is less than the critical value. So that's B. Okay, that's the classical approach. P-value is 5.55 times 10 to the power negative 17. That's like 0.000000000000000. It's 2 is 0. Just put 0. Okay, 0. That's it. Question 17. Determine whether the following sampling is dependent or independent. Indicate whether the response variable is qualitative or quantitative. A researcher wishes to compare mental health of doctors and non-doctors. She obtains a random sample of 893 professionals of each category who take a mental health inventory and determines each individual's mental health. Okay? Determine whether the following sampling is dependent or independent. So she obtains a random sample of 893 professionals of each category, so of the doctors and of the non-doctors. Okay? So it says here, the sampling of course is independent because an individual selected for one sample does not dictate which individual is to be in the second sample. Okay? She obtains a random sample of 893 professionals of each category. This is independent sampling. Okay? So, indicate whether the response variable is qualitative or quantitative. They take a mental health inventory. So, with the mental health inventory, you ask yourself, like, is it qualitative or quantitative? Okay? If there's gonna be some comparison, mental health, you ask yourself, maybe the mental health is being graded on something. You understand what I'm saying? That maybe it's being graded on something, or how is it, like, is it being graded on a scale, or does it qualify, does it use to classify the individual? Mental health, I would think that it's used to classify the individual. A mental health inventory. I would think that it's not like on a scale. Probably it will be used to classify the individual. That's what I would think. I'm not really sure of this, honestly. Because with the mental health inventory, you kind of ask yourself, is it like, with mental health, this is something that you probably might want to Google or Bing to research. Mental health inventory, is it used, like, how do you grade someone mentally? You know, I'm sorry, I've not been I've not been in that situation, and I've not kind of witnessed such, you know. Whether the individual is mentally sound or not mentally fit, is there some grade level or numerical measure to? It's not probably IQ. Well, if it's IQ test, then you could say it's numerical. But if it's not IQ test, then you could, if there's some scale, if there's some way to classify the individual, then it could be qualitative. So this question, I would just say qualitative. This question 17, I'm not really sure of that, but I'll just put qualitative because it classifies the individual. If they mentioned IQ test, then I would put quantitative, something like that. If they mentioned IQ test, because IQ is numerical, okay, because it's numerical. But if it classifies the individual, it's more of qualitative, describes the individual. So this is question 17, okay. Let's move ahead. Question 18, In randomized double-blind clinical trials of a new vaccine, children were randomly divided into two groups. Subjects in Group 1 received the new vaccine, while subjects in Group 2 received a control vaccine. After the first dose, 114 of 709 subjects in the experimental group, which is the Group 1, experienced fever as a side effect. After the first dose, 59 of 604 of the subjects in the control group, Group 2, experienced fever as a side effect. Construct a 99% confidence interval for the difference between the two population proportions, P1 minus P2. So, and they want us to use X1 as 114, N1 709, X2 is 59, N2 604. Okay, I'm gonna make this to restore this. Let's get on my calculator. I'm gonna just refresh this. And here we're gonna use because this is testing a claim about a population proportion. This will be two samples confidence interval. Okay, this is what we're gonna use. I will now restore this browser. So the number of individuals from population 1 is X1. X1 is 114. Sample size from population 1 is N1. N1 is 709. X2 is 59. N2 is 604. Okay. Confidence level is 99%. 99%. Calculate. So they want us to round to 3 decimal places. So confidence interval, the lower limit of the confidence interval to 3 decimal places would be 0.016. Okay, 0.016. And the upper limit will be 0.110. 0.110. Okay. Question 19. A researcher studies water clarity at the same location in a lake on the same dates during the course of a year and repeats the measurements on the same dates 5 years later. The researcher immerses a weighted disc painted black and white and measures the depth in inches at which it is no longer visible. The collected data is given in the table below. Complete parts A and B below. So we've kind of done this in the homework. We've done this in the homework. We want to use the same dates because it makes the second sample to be dependent on the first. That is B. And of course, that's why we want to take measurements on the same dates. And then the next one is, does the evidence suggest that the clarity of the lake is improving at the 5% level of significance? Note that the normal probability plot and box plot of the data indicate that the differences are approximately normally distributed with no outliers. So here, just do not reject the null. Okay. Question 20. A researcher wanted to determine if carpeted rooms contain more bacteria than uncarpeted rooms. The table shows the results for the number of bacteria per cubic foot for both types of rooms. So this is the number of bacteria per cubic foot for the carpeted room, and this is the number of bacteria per cubic foot for the uncarpeted rooms. The null hypothesis. State the null and alternative hypothesis. Let population 1 be carpeted rooms and population 2 be uncarpeted rooms. So the null hypothesis is that there's no difference. Okay, the mean 1 is equal to the mean 2. And then the alternative hypothesis, you want to know whether it contains more bacteria, whether the carpeted rooms mu1 contains more bacteria than uncarpeted rooms mu2. So this will be here. Okay, 2 samples but right-tailed. This is 2 samples right-tailed, and this is estimating population, testing population mean. 2 samples right-tailed. Let's go on my calculator. I'm gonna refresh this. Testing population mean. Testing a claim about population mean. 2 samples right-tailed. Oh, I don't have 2 samples right-tailed here. Oh wow. Okay, I'll need to put it. I'm continuously adding stuff here. I'm continuously adding more stuff here. There are still more that I need to add. So much more I need to add. 2 samples right-tailed. I don't see it here. 2 samples right-tailed for population mean. Okay, we're gonna do this with Statcrunch, with your Statcrunch. They want us to determine the p-value for this hypothesis test. Okay, so I'm gonna go to full data set, open in Statcrunch. Okay. We will do this here, start, and this is t-starts, 2 sample with data. Sample 1 is the carpeted, sample 2 is the uncarpeted. Perform a hypothesis test. Mu1 is equal to mu2, that is the null. Alternative is greater than mu1 minus mu2 is greater than, because it is right-tailed. Okay, right-tailed, 2 samples right-tailed. So you make sure you select right-tailed. Okay, greater than. And we do want a p-value plot, but let's go ahead and put this compute. Yeah, we can leave the p-value plot. So when you click compute, you have this is 0.0543, but to 3 decimal places will be 0.054 as the p-value. So 0.054. Okay. Do you reject the null or fail to reject the null? The p-value is 0.054 and the level of significance is 0.05. So p-value is greater than the null, the level of significance. Okay, 0.054 is greater than 0.05. So if the p-value is greater than the null, you do not reject the null. Do not reject the null. Okay. When you do not reject the null, that means there is not sufficient evidence. Okay. When you reject the null, that means there is sufficient evidence. When you reject the null, that means there is sufficient evidence if you reject the null. But when you do not reject the null, that means that there is not sufficient evidence. So do not reject the null. There is not significant evidence at the 5% level of significance. to conclude that carpeted rooms have more bacteria than non-carpeted rooms. So this will be A. Okay. Question 21. For the following data set, draw a scatter diagram, compute the correlation coefficient, and then comment on the type of relation that appears to exist between X and Y. So for the scatter diagram, we'll just do it with Statcrunch. So open it, I'll click here, open in Statcrunch. We'll go to graph, we'll go to scatter plot. The X, we select X variable, we select X. Y variable, we select Y. And we'll just click compute. So let's compare. Let's compare. Restore this. Let's compare the what we have here with what we have here. So A is out. We eliminate A. A will not work. We eliminate D. A and D are out. So we are left with, we are left with B and C. So let's maximize B and C. Let's maximize B. Let's expand it. We look at this to see whether it resembles that. B kind of looks similar, but let's see C. Let's look at C. C really does not. You see the way C is. C really does not. Okay. B looks more similar than C. Okay. You look at B. B looks more similar. So the answer is B. Okay. The next one, compute the correlation coefficient. Compute the correlation coefficient. I'm just gonna use my, because they might ask us more questions on that. So I'll use my calculator. I'll minimize this. Get on my website. And I'm gonna use correlation and regression calculator right here. Correlation and regression calculator. We can use first formula or second formula, it doesn't matter. You can use first formula or second formula, it doesn't matter. It will work. Let's restore this. And here for the X, I'll put 2, 5, 7, 7, 9. For the Y, I put 1.5, 2.2, 2.4, 2.6, 3.2. Okay, and I'm just gonna scroll down and I'll click calculate. So the correlation coefficient to 3 decimal places is 0.978. 0.978. Okay. What type of relation appears to exist between X and Y? So the absolute value of the Pearson correlation coefficient is greater than the critical value. This is the critical value for the correlation coefficient for n equal to 5. And 0.978 is greater than 0.878. So a positive linear relation exists between the variables. So the linear correlation coefficient is close to 1. A positive linear relation exists between X and Y. Okay. Question 22. What does it mean to say that the linear correlation coefficient between two variables equals 1? What would the scatter diagram look like? Of course, when you have a linear correlation coefficient of 1, that is a perfect positive correlation. Perfect positive correlation. And the scatter diagram will contain points that lie on a line with positive slope. Okay, perfect positive linear relation between the two variables. Perfect positive. Scatter diagram will contain points that all lie on a line with a positive slope. That's B. Question 23. A student at a junior college conducted a survey of 20 randomly selected full-time students to determine the relation between the number of hours of video game playing each week, which is your X, and grade point average, which is the Y. She found that a linear relation exists between the two variables. The least squares regression line that describes this relation is this. A. Predict the grade GPA, predict the grade point average GPA of a student who plays video games 8 hours per week. Okay, so this is actually, you can use this calculator. This means X equal to 8. Okay, X equal to 8 because that's the hours of video game playing each week, X. So we can do 0.0507 times 8 equal to, and I'm gonna put this, store it in memory add, store the memory, and then I will just do 2.9453 minus recall memory. And you mustn't, it depends on how you use it. I'm using this calculator to show you, but I know you can put this on your calculator as well. But just make sure you use this. I'm gonna show you in a moment also. You use this, you don't use minus this if you're gonna put it as is. Okay, the way I did it, I first of all multiply this times 8, then I now did this minus that to give me this 2.5397. To the nearest 100th would be 2 decimal places, which is 2.54. So GPA will be 2.54. Okay. Well, we can clear our memory. We can do that. We can also do this like this. I'll clear this. So I'll put negative 0.0507 negative this times 8 equal to this. Okay, then plus 2.9453 equal to this. I'll do it again. I'll clear this. You put, you know what, don't put this yet. Well, some calculators you have to put this first. Now some calculators have parentheses minus close parentheses. Some calculators have it that way. But let's do this again. You just put 0.0507 and press this to have the negative there, then plus 2.9453 equal to this 2. Let me do it again. So 0.0507 negative times 8. I have to do times 8 equal to this. Okay. Then plus 2.9453 equal to this. Okay, 2.54 GPA. All right, interpret the slope. The slope is negative 0.0507. That's the slope. For each additional hour that a student spends playing video games in a week, the grade point average GPA will decrease. You see, this is a decrease, negative slope, will decrease by 0.0507 on average. Okay, 0.0507 2.507 points on average. That is what it means. C, if appropriate, interpret the y-intercept. So the y-intercept is when x is 0, okay? And that is just this, 2.9453. The grade point average of a student who does not play video games is 2.9453. Yes. Okay. D, a student who plays video games 7 hours per week has a grade point average of 2.71. Is the student's grade point average above or below average among all students who play video games 7 hours per week? Okay, so let's find that out. We're gonna do this again, but our x will be 7 in this case. So I'm gonna clear this. I'll do 0.0507, put your negative there, times 7 equal to this, then plus 2.9453 equal to this. So 2.5904, 2.59. So a student who plays video games 7 hours per week has a grade point average of 2.71. So that student's grade point, is the student's grade point average above or below average among all students who play video games 7 hours per week? Well, 2.71 is above this, okay? So it is above average, okay? It is above average because 2.71 is above 2.59. Okay. Question 24. Analyze the residual plot below and identify which, if any, of the conditions for an adequate linear model is not met. If you look at this residual plot, which of the conditions below might indicate that the linear model would not be appropriate? I would say constant error variance. Okay, constant error variance. Question 25, we are getting there. For the data set shown below, complete paths A through D below. Find the estimates of that's the y-intercept and also the slope. Compute the standard error, the point estimate for the standard deviation. Okay, so I could do this with my calculator, but some of it, I think Statcrunch does all of it. I don't think my calculator for now does all of it, which I'll have to, let's see, which I'll probably have to work on so that it will do all of it. They asked about standard error. Standard error. Okay. I don't think I have standard error here. Okay, that's fine. Let's use Statcrunch here. Let's use Statcrunch. So I'll come here and I'll open in Statcrunch. We can restore this, pull this to be produce. Okay, we will go to Start, Regression, Simple Linear. X variable we select X, Y variable we select Y. If we look at this question D, assuming the residuals are normally distributed, test this. The coefficient of the slope B1, beta 1 is 0 versus beta, the null hypothesis beta 1 is 0 versus the alternative hypothesis beta 1 is not 0. at 5% level of significance. Use p-value approach. So we can go ahead and test this. Slope is 0. Slope is not 0. So this is a two-tailed test. So that's fine. We leave it like it is here. I think that is what they asked us here. Okay. So we just leave it like it is. Here. They didn't ask us to predict, right? Okay. So we just click compute, and we want to look at everything here. Want to look at everything here. The y-intercept round to 3 decimal places. That is this here. Y-intercept to 3 decimal places will be negative 1.070. Okay, negative 1.070. The slope, the coefficient of the slope, actually not the coefficient of the slope, the slope to 3 decimal places is 1.791. The standard error, the point estimate for the standard deviation is this here. Okay, and that is to 4 decimal places would be 0.8259. Assuming the residuals are normally distributed, standard error for the slope, B1 is this right here, and to 3 decimal places it will be 0.199. The p-value, when you do this test, the p-value for the slope is right here, and they want it to 3 decimal places, so it will be 0.003. Okay. You compare the p-value at the 5% level of significance. So the p-value is less than alpha. Excuse me. The p-value is less than alpha. 0.003 is less than 0.05. So you have to reject the null. Okay, reject the null. And once you reject the null, there is sufficient evidence. Reject the null. There is sufficient evidence to conclude that a linear relation exists between x and y. The thing there is, you look at all these things. Anytime at all, anytime you reject the null, then there is sufficient evidence, okay, to support the rejection of the null. And then if you do not reject the null, that means there is not sufficient evidence to support the rejection of the null. The p-value is less than the level of significance. So in that case, when the p-value is less than the level of significance, then you reject the null, and that means there is sufficient evidence to conclude at the 5% level of significance to conclude that a linear relation exists between x and y. Okay. Comprenez-vous? Do you understand? Comprenez-vous? Question 26. We are getting there. The data in the accompanied table represent the rate of return of a certain company stock for 11 months compared with the rate of return of a certain index of 500 stocks. Both are in percent. Complete parts A through D below. Treating the rate of return of the index as the explanatory variable x, use technology to determine the estimates of beta naught and beta 1. Okay, we're gonna do this. We'll click on this, we open it in Statcrunch, and I'm gonna restore this so I can have this side by side. Okay, I'm gonna close this now. We'll go to Start, Regression, Simple Linear. X variable is our rate of return of the index. That's your X. Y variable, rates of return of the company stock. Y. And let's see, we'll state the null and alternative hypothesis, determine the p-value. Okay, so we're gonna perform a null hypothesis. We're gonna perform hypothesis test, and in this case, we want to know, assuming the residuals are normally distributed, choose this. We want to know whether it is one-tailed or two-tailed. Okay, we want to know whether it's one-tailed or two-tailed. So here we're looking for more or less. Okay, assuming in the B part, assuming the residuals are normally distributed, test whether a linear relation exists between the rate of return of the index X and the rate of return of the company stock Y at the 10%, 0.1. Okay, at the 10% level of significance. So in this case, they didn't say more or less, so we'll take it as two-tailed test. We'll take it as two-tailed test because they didn't say more or less. So here we'll leave it as that. Slope is 0 and slope is not equal to 0. Okay, we'll leave it at that. Are we predicting anything? We are not. We will still construct confidence interval. Well, we'll do that later on. But let's go ahead now and click compute and look at this. Here, the estimate of the y-intercept. This is actually the y-intercept right here. Okay, 4 decimal places will be 1.2488. That would be 1.2488. The slope to 4 decimal places is this, and that would be 0.7699. 0.7699. Here will be two-tailed test, so this is C because they didn't say more or less here. So you see, p-value for this slope is here, 3 decimal places. This is this, and this would be 0.026. 0.026. Okay. The p-value 0.026 and the level of significance is 0.1. So the p-value is less than the level of significance. So reject the null, and you reject the null because there is sufficient evidence to conclude that a linear relation exists between the rate of the return of the index and the rate of return of the company stock. Okay, if the p-value is less than the level of significance, reject the null. C, assuming the residuals are normally distributed, construct a 90% confidence interval for the slope of the true least squares regression line. Okay, I'm going to close this here and we're going to construct a 90% confidence interval. You go to start, go to regression, simple linear, get your x variable, get your y variable. In this case, we are not performing the hypothesis test. We'll check on this confidence intervals. And 90% is 0.90 or 0.9. Do we need to predict anything? D, what is the mean rate of return for the company stock? That is your Y. If the rate of return of the index, the X, is 3.25%. So we can still predict this. So you put 3.25 here, and the level is still at 90% confidence level. Okay? 90% confidence level. Alright? You want to construct the intervals at 90% confidence level. What would be the 90% confidence interval for the slope of the true least squares regression line? Okay, so you put this and you click compute. And then we can look at this. We expand this. So the slope is what we're looking for. This is what we need here, okay, of the slope. The lower limit to 4 decimal places will give us 0.2412. The upper limit to 4 decimal places will give us 1.2986. 1.2986. Okay. Then the predicted y. You scroll down to see the predicted y right here. To 3 decimal places, predicted y. When x is 3.25, what is your y? So you can actually use this. You can actually use this equation to do it. When you put x to be 3.25 times 0.76992373. And then you can add it to this 1.2488405. Yeah, you can actually do it that way. But you know, you can still do this like this with the Statcrunch predicted value for y. So to 3 decimal places will be 3.751. Okay, and that is it. Okay, question 27. Why is it desirable to have the explanatory variables spread out to test a hypothesis regarding beta 1 or construct confidence intervals about beta 1? Why? Actually, we do that so that the standard deviation of B1 is smaller. Okay, so that is option A. So the standard deviation of B1 is smaller. Okay. Question 28. Last but not the least. Suppose a multiple regression model is given by, they give you that multiple regression model. What would an interpretation of the coefficient of x1 be? Fill in the blank below. An interpretation of the coefficient of x1 would be, if x1 increases by 1 unit, then the response variable will increase by, of course, 4.55, okay? Because it's the coefficient of x1. On average, while holding x2 constant. Okay? And once you finish this, you click on this to make sure you've answered everything. You can press the enter key here. Okay, you can go back here to save that 28, to save that question 28. So you've answered everything, okay? And you can then submit the test. You submit it, okay? Okay, so you will now say, hey, Mr. C, the professor. Mr. C, the professor. Okay, let's look at 28. Now, after submitting the test, that is one attempt. Okay, so you kind of look at what you've done. With this, I didn't, I kind of just guessed, I know. But I know you guys will say, hey, the professor took it and didn't make 100. Well, I did a video of this. This you can actually read in your notes. You read it. You read your notebook about this. I didn't use I'm not using my notebook. You want to go, let me show you after you finish taking the test. Okay, let's refresh this. Okay, so you have to log in again. So you have to log in again. Okay, and this is my 240 course copy. That was what I used. And you go to the quizzes and tests. Now, this is what you do after you finish one attempt. One attempt, see score. So that is the score, okay? And I know you guys. Okay, so I'm doing this at this time. So don't laugh at me that, hey, Mr. C took the test one time. He didn't even make 100. Whatever. Now, so before you start test, don't start the second attempt. No, don't do that. Let me show you what you do. So go to gradebook. You go to gradebook. You go to your gradebook. And you go to review. Under the final exam here, you click on review. You see I made 100 in this one. And this is the same date. That's today. I'm taking this today, both of them. See? So you click on review here. You can actually make hundreds on this. That's what I want you to do. So I'm going to just allow pop-ups. If you have pop-ups that are blocking it, allow pop-ups. Okay. And then click on review. You click on review. And you look at the questions you got wrong. Okay. You look at the questions you got wrong. Question 14. Question 24. We've seen it. This is something you can read in your book and see. Question 14 and question 26. So let's look at question 14. And you look at what I answered was that. So I think I probably used my calculator. I'm gonna look at this again. This is right-tailed. Okay, I probably used left-tailed. Let me look at this again, because with my calculator it's supposed to give you correct answers. Otherwise I'll blame myself. This is right-tailed test. Right-tailed. I hope I did not use left-tailed. This is proportion, but it's right-tailed. One sample right-tailed. Okay. Let's do it again and see. Maybe I used left-tailed. So population proportion is 0.3 in decimal. Number of individuals, this is 45. Sample size 100. Level of significance is 0.1 in decimal. Calculate. P-value. You see, I use left tail. That's the problem. Yeah, the p-value is 0.001. Yeah, I think I used left tailed instead of right tailed. Okay, so that tells you I'm a human being. I am not God. Only God does not make mistake. Okay, only God Almighty is above mistake. See, I used but my calculator is still right. I used right tail instead of left tail. Okay, I used right tail. The left tail is 0.001. I used sorry, I used left-tailed. I used left-tailed instead of right-tailed. This is supposed to be right-tailed, but I used left-tailed. This is 0.3 in decimal. This is 45. This is 100. This is 0.1. 0.1 in decimal. Yeah, 0.999. Yeah, I used left-tailed instead of right-tailed. So you use right-tailed, okay, because of the greater than. So I'm a human being. I make mistakes. I'm not God. Only God does not make mistake. Now let's look at let's see the other one. You go to review. The other question I got wrong. Click here. Question 26. Of course, this is beta 1 for the slope. I did it as y-intercept instead of slope. You see that? So, you know, this is something that, you know, I found out my mistakes, the 3 mistakes I made. And you make sure before you take the next test, you correct it. Okay, you review what you got wrong. This is beta 1, not beta naught. This is the y-intercept. It should be the slope. It's two-tail test. Okay, so you know, you do it before. I will encourage you to use the 2 attempts for your exam, and after the first attempt, feel free to ask questions. Okay, and I wish you the best. Okay. Thank you so much for listening to this video session. And you have a good evening.